So let's review kinematics and hopefully forces. I'm going to be watching my clock and I'm going to get as far as I can. So some key concepts that we talked about in kinematics. How do I add two vectors together? And usually I did my Nerf dart gun to add some dramatic effect. How do I add two vectors together? Okay, so we can write down draw them tip to tail. How do I subtract two vectors? Add the opposite. So make the second one negative. What do I mean by negative? If it was north, now it's south. If it was east, now it's west. Did I say angle? Okay. And then we started looking, we did some applications of vectors. We did the river question. I'm not putting that on your final exam. We did the airplane crosswind question. What I am going to be putting on your final exam are projectiles. So the best tool for projectiles, I said, was a T-table. That was my go-to if I saw a projectile. What do I mean by a T-table? A T-table looked like this. It had a horizontal column, it had a vertical column, and it looked like a letter T. The lines did. Help me out, people. Okay. It was your main velocity times the sine theta if we were at an angle. We should say, note, if we were horizontal, Vy initial was 0, which made it a way easier question, but people kept forgetting that, making it a way tougher question. Horizontally from a cliff is the easiest of the projectiles because you've got a 0. I am going to give you horizontally from a cliff on your final exam. If Vy was sine, what was Vx? Of course it is. Vx is whatever your velocity was, cos theta. What were the two physics no-brainers? There was two things I could write. I could write this, ax equals, and I could write ay equals. Now, I can't quite call them no-brainers. You had to know some physics, but what was your horizontal acceleration? Uh-oh, we're in trouble because these were no-brainers. Hey, what was the vertical acceleration? At least get that one. Can't be a 9.8. Okay, AY was negative 9.8. Horizontally, what forces were acting on a projectile horizontally? None. So what was your horizontal acceleration as a number? Which again, made it way easier, but you had to remember that. Yes. So AX equals 0, AY equals negative 9.8. I've got to pause the video. Oh, hit the wrong button. I've got to pause the video. Sorry for those of you on YouTube because I have a bunch of students showing up late. And yes, I'm irritated. Continue. So we're live again, and then the key thing we said, don't put a horizontal value into a vertical equation and vice versa. So you're going to get a projectile launched horizontally from a cliff. Here is an example. A projectile is launched horizontally. Let's write in the numbers. Looks like the velocity is 67 meters per second. Looks like the cliff height is 124 meters. And it says find the range. Okay. How are we going to do that? It's a projectile. Our first tool is going to be a T-table. I'm going to do my T-table right here. Horizontal, vertical. What were the two physics no-brainers? What can I write? AX equals 0. AY equals negative 9.8. The rest I adapt to the question. Here, we're launched horizontally. My Vx is 67 meters per second. I don't need to do any trig. What's my initial vertical velocity if I'm launched horizontally from a cliff? 0, which makes the question way easier. What are we going to spend most of our time trying to find? Time. So they gave me one more piece of information. They gave me this 124. Is that a vertical value or a horizontal value? Be stupid obvious. vertical, so it's going to go here. dy is going to be, why is it not 124? Why is that incorrect? Sorry? Negative, because it's a displacement running up below from where I started. Matthew, which column do I know three things in, the horizontal or in the vertical? I'm going to solve for time vertically. So I'm going to go t equals question mark. I'll walk over here. Folks, I'm looking for an equation that's got an a, a v, a d, and a t in it. There is one. Kanan, which one? D equals, why did I just write a half AT squared? Why didn't I bother writing the VIT? Okay, and that's the key. Kids always want to put the 67 in there, or I see kids do something stupid like that. I don't use that word very often. Like somehow they try finding a hypotenuse of a. I don't know what they're trying to do. When we're launched horizontally, Alexis, I'm doing you a favor. Vy is 0. So I just get that. In fact, Kanan, I'd write it as AT squared over 2 because that's a little cleaner. Kanan, get the T by itself. How will I move the A over? Oh, by the way, I told you, put the little subscripts in to remind yourself, put the vertical values into a vertical equation, put the horizontal values into a horizontal equation. How would I get the T by itself? What will I do with the A? What about the 2? We get this. Time is going to be 2 times the vertical distance divided by the vertical acceleration, square root. It's going to be the square root of 2 times 124, negative 124, Mr. Dueck, divided by negative 9.8. I have no idea what the time is, but let's quickly go find that. And I get, double check me, 5.0305, blah, blah, blah. Anybody else? Okay, so I'll write 5.03, but I'll store this on my calculator. Alexis, we're not done. What did this actually ask me to find? Now I'm going to go horizontal. So I can move the time to here, 5.03. Now I know three things, and I can find the horizontal range, dx. I'm looking for an equation, Alexis, that has an a, a v, a t, and a d in it. There is one. You'll get it. And then when you see it, you'll go, oh, yeah. Read me the one that starts d equals. Sorry? I think you're right. You trailed off. Yeah, except why can't I just go vxt? Why can't I just do that? Yes, and that's what made the horizontal so much nicer in that your quadratic term, the t squared, vanishes. Ooh, it's going to be 67 times answer button. 67 times answer button. And I get a range of 337 meters. No? Yes? Following along on your calculator? Of course you are. Oh, Owen, what if instead I gave you the range? Could you find the height? Well, then you'd start with this to find time. Because you would know the range, you would know Vx. How would I get the t by itself? Even easier. And then I would walk time over here, and I would go to this equation, and I would have ay, negative 9.8, the time from horizontal, and I could find the height. I get a negative displacement, but that would be the height as well. I'll flip-flop. I have several versions of my final, so some people will be given a horizontal projectile and asked to find the range, given the height. Some people will be given a horizontal projectile, asked to find the height, given the range. So we looked at those. Example 2. We also did from the ground at an angle. Hey, everybody, did I say angle? Components. Okay, let's fill this in. It says a projectile is launched from the ground at an angle of 36 degrees with an initial velocity of 99 meters per second. Okay. Nicole, what does A want me to find? Before I do anything, is this a projectile? Yes, I'm going to do a t-table. I can say AX equals 0, AY equals negative 9.8. Am I going to use that 99? Never. Why? It's at an angle. Hey, did I say angle? So what I'm going to find is Vx, and I'm going to find Vy initial. Why does the y have an initial? Because there is an acceleration, negative 9.8. Why does the x not have an initial? No acceleration. It's going to be constant the whole way through. Anywhere in this question, if I'm moving horizontally, I'm going to be traveling at what this is. Now, we did the trig once. What was the stupid way to remember? What was Vy? So it's going to end up being, and I got to move over a little bit to get this on the screen, Mr. Dueck. It's going to end up being 99 times the sine of 36 degrees. Vx is going to end up being 99 times the cosine of 36 degrees. Let's crunch those. So I'll get 99 cos 36, and I'll carry some extra sig figs, 80.093. And Vy initial, I can just backspace and edit and change the cosine to a sine. I like that. And I get 58.191. And I think I said degrees, meters per second. 58.191 meters per second. I think I said 80.093 degrees, 80.093 meters per second. I've got two things in this column, acceleration and velocity. I've got two things in this column, acceleration and velocity. I need three things to find the fourth. So, Nicole, what do they ask me to find? I have a feeling I'm going to find time vertically to get the distance horizontally. How? There must be something else that I know vertically. What else do I know vertically? Right? And by the way, our argument was if we were launching from an angle, did I say angle components? Really, vertically, the projectile was just doing this. That's what we were treating it as. Horizontally, the projectile was just moving sideways at a constant speed. And it's when we combined those that we got this parabola shape. So think about this. What do I know? Brushing cobwebs off, I know. A little more cobwebs than I was hoping for. Okay, so one thing I know is, don't say 0, I'll go cray-cray. I know the final vertical velocity when it hits the ground. Yes, negative 58.191. Because we're starting and ending at the same place. What goes up must come down. I'm going to hit the ground at exactly the same velocity that I left. Now, I know 1, 2, 3 things. I can find the fourth. I can find time. I'm looking for an equation, back to you, Nicole, that has an A, a V initial, a V final, and a T in it. There is one. The first one, isn't it? Can you get the T by itself, please? It's going to be Vy final minus Vy initial divided by AY. So here's part A that we're doing. Time is going to be Vy final negative 58.191 minus Vy initial 58.191 divided by negative 9.8. In fact, because I have this number sitting on my calculator, I can cleverly use my answer button, I think. I think I can go bracket negative answer button minus answer button, close bracket, divided by negative 9.8. And I get a time of 11.8756. I'll call it 11.876 seconds. We're not done. What did you say they wanted us to find, Nicole? Range is horizontal. It's going to be dx. How can I find dx, Alexis? It's going to be vxt. Good. Dx is going to be vxt. It's going to be 80.093 times my answer button. $80.093 times answer button. And I get 951 meters. Is that okay, Annie? Yeah, yeah. What else can I ask? Annie, what does B want me to find? So I'll do that right here. I'm really kind of unorganized, but that's okay. Ooh, maximum height. Is that going to be vertical or horizontal, do you think? Which one of those is, yeah, vertical height. So I would quickly say to myself, okay, I'm going to use AY equals negative 9.8. I'm going to use VY initial equals 58.191. They want me to find the maximum height. I'm going to say it's asking me to find a dy. I need three things to find the fourth. What else do I know vertically if I want to find the maximum height? I got to be fussy. VF isn't zero. VY final is zero. Back to you, Annie. I'm looking for an equation that's got an A, a V initial, a V final, and a D in it. There is one. Yeah, it's our squared. Get the A by itself, please. It's going to be VF squared vertical. Mr. Dueck, let's put the Y's in so I'm not tempted to put in silly numbers. VY final squared minus VY initial squared all over 2. I'm finding D, Mr. Dueck, not A. Put the letters in the wrong place. dy equals Vy final squared minus Vy initial squared all over 2 ay. It's going to be 0 squared minus 58.191 squared, all divided by 2 times negative 9.8. Coming back to you. I hope. It's been a while. Annie, what'd you get? So 173. Anybody else? Need a confirmation. Yep, 173 meters. Okay. What else could I ask? I could ask a trick easy question. Part C. Nathan, what's part C asking? What is the velocity at the top? It's not zero. You know the answer already. Okay, so you ready? Everyone look up. Everybody look up. So here's what it's looking like. Right here at the top, it's come to a stop vertically. Has it come to a stop horizontally? So what's the velocity at the top? What's the only velocity left? He just figured it out. What is it? Of course it's 80.093, because that's why this is such an easy question. The velocity at the top for a split second is 80.0. You know what? I'll call it 80. I'll write 80.093. So when you're studying, you know where the heck that number came from meters per second. That's the only velocity left at the top for a split second. There's no vertical velocity. Then the total velocity is just the horizontal component right there. Is that all right? That is a very quick review of kinematics. So you're going to have either, well, you know what? You're going to have two questions to choose from. I think I've talked to you about your final, but I'll talk it again. You're going to open it up. It's going to be a booklet format, and you can do either number 1A or number 1B. It's going to be a horizontal from a cliff projectile or a ground at an angle projectile. You can pick one of those two questions. Cross the other one out. Forces. Turn the page. So, some key concepts. You need to know Newton's laws. Newton's first, which way are you accelerating? That's the direction of the unbalanced force. If you're not accelerating, forces must be looking for the letter B, balanced. Newton's second, winner minus loser equals ma, is how we modified it. Newton's third, forces come in pairs, technically opposite pairs. You need to, this is a job for a free body diagram, was something I've tried to emphasize. Our generic equation was who's winning? That's going to be the positive direction. What do I mean by who's winning? Which way are we accelerating? That's going to be the positive direction. Who's losing? That equals F net, that equals ma. And then when we had angles, did I say angles? What were our components? We broke them into parallel and perpendicular. My symbol for parallel was two lines. Which trig function was mg parallel? It was going to be mg sine theta. And then mg perpendicular, of course it is. It's going to be mg cos theta. So I've got 3 or 4 different forces questions that I'll cycle through the various versions. One is definitely going to be an Atwood machine, but at an angle on a ramp. One is definitely going to be on a ramp, but instead of asking you to find A, I'll ask you to find time, or VF or VI or D. You'll have to find A first. And then one is going to be a lawnmower question. So that's 3 different questions. I'll cycle them through my various versions. You'll see 2 of these. So let's do the Atwood machine at a ramp. It says if M1 equals 12 kilograms, I might even draw that in. If M2 equals 16.5 kilograms, I might even draw that in. And theta equals 61 degrees. And the coefficient of friction, mu, equals 0.24. It says find the tension in the rope. I'm not going to find the tension in the rope. What am I going to find first? How did we solve these 2 mass questions when we wanted to find tension? What do we have to find first? Peyton, I think you were right. No? Oh, I thought you whispered something to Ronan. Well, any suggestions on how I'm going to start? Ooh, I'm concerned here. Even before that, I think we're going to do a free body diagram. And then our strategy was we find the acceleration of everything by writing an equation for everything. In that equation, tensions cancel. So we can't use that. I had the terrible joke. And then to find tension, I'll do an individual mass to find an individual force. Probably this one, because this one's going to end up being cluttered. All righty. So on the left, what are the forces acting on M1, Arnica? Get the obvious one. Thank you for remembering that one. That's going to be M1G. What else? Good. Then we walked over to M2. What are the forces acting on M2? Get the obvious one. And I told you always draw it through. I encourage you, go through the base. It gives you an extra 90-degree angle to eyeball. And we always put the MG on the same side as the pointy part of the ramp. And that's going to be M2G. And now we pause because I said ramp. We're going to break it up into components. I'll change colors. We broke it up into perpendicular, which means we're going to stop right there, and parallel. And remember, parallel is parallel to the ramp, not parallel to the base. So there's a 90-degree angle right here. This was MG perpendicular. This was MG parallel. And then I always went color, 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 color. Where else am I going to color? Color, 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 color. Those 2 angles are the same. We did that proof once. We said we got that. What else? Arnica, there's a rope. So what do we call the force from a rope? So I know I'm also going to have tension pulling this way. That's a consequence of Newton's forces come in pairs. And then there's a coefficient of friction. So there's going to be friction. Here's the problem. I don't know which way this is sliding. If it's sliding up the hill, friction's pointing down the hill. If it's sliding down the hill, friction's pointing up the hill. So this is where Owen was saying, I think we need to figure out which way it's moving. We need to do a comparison. What's the tug of war between? It's between the 2 gravity components, M1G pointing down and parallel down the ramp. So get your calculator out, all of you. Let's quickly crunch M1G. 12 times 9.8. I got 117.6. I'll remember that. I'm lucky. I can store it on my screen because I've got a multi-level screen, but I'll remember that. The other one, oh, and you know what, Arnica, I was sloppy. I should have said M2 and M2. And I'm missing one more force, by the way. I'm missing a normal force, aren't I? You guys were screaming at me. Is it sinking into the ramp like quicksand? Is it flying? So I should have drawn in the normal force, and the normal force is going to be the same size as M2G perpendicular. This is normal force number 2 to go with mass number 2. That was sloppy of me. The other one I want to compare, Kanan, is this one here, M2G parallel. What's the symbol for parallel to what? Sine. It's going to be M2, 16.5, times 9.8, times the sine of 61. And I want to see which two of these is bigger, because that's going to be the winner. So gravity pulling down with M1G is 117.6. Oh, 141.4. You know what? The winning mass gravity is M2. This is accelerating in this direction. I would probably draw that in, which means M2 is sliding down the ramp, Matt, not up the ramp. So friction resists sliding. That means friction force number 2 is up the ramp. And now I'm going to write an equation by walking along the rope. That's my equation. Which way is M2 sliding? Down the ramp. Which way is the winning direction, Alexis? Same thing, down the ramp. So now, Arnica, which is the only force down the ramp? Who's winning? M2G. Parallel. Sorry, I should have said M2G parallel. Walking, walking. This tension here is up the ramp, loser minus. This friction force 2 is up the ramp, loser minus. Keep walking, keep walking, keep walking. This tension here, if I follow it, ends up being down the ramp, winner plus. And this one here, M1G, is if I follow it, ends up pointing up the ramp, loser minus. That equals M all A. Now, we may run into a situation here where friction and M1G are so big that nothing's sliding. We'll find out if we get a negative acceleration. I won't try and do that to you on the test. I'm just realizing I made up numbers and I don't know if I crunched this ahead of time to see if it works or not. First of all, everybody put your pencils down. Everybody. Join me. Come on. Stretch it out. Kanan, you too. Why can we stretch? Everybody. Okay, terrible joke, but we needed that right now. Arnica, back to you. I want to get the A by itself. How am I going to get the A by itself? Okay, and by M all, I mean M1 plus M2. So, A is going to be M2G parallel, M2G two lines. It's going to be sine. It's going to be M2G sine theta. I'll put numbers in on the next line. Minus Arnica, friction is what times what? I don't know the normal force. Oh, but look, 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 look. I don't know the force the same size as normal force number 2, and it's not mg. What is it? It's m2g perpendicular. Perpendicular, which trig function is that going to be? Of course it is. So it's going to be mu m2g cos theta. If you want to, in your notes, you can draw an arrow pointing on this line, and you can say, hey, that's going to be mu mg perpendicular, and that's where the m2g perpendicular, and that's where the cos came from. Minus, and I don't need to do anything fancy with m1g, all divided by m1 plus m2. How much more room have I got? I think I got enough. I've scrolled down. What was M2, Arnica? 16.5, thank you. G, 9.8, not negative. We took care of that with our winner minus loser. Sine was theta 61 degrees. Minus 0.24 times 16.5 times 9.8 cosine 61 degrees minus, what was M1? 12, thank you. Let's get myself a smidge more room, Mr. Dueck. Yoink. Let's see. If we get a negative answer, what that really tells us is not that we picked the wrong winner, but that nothing is moving. I'm hoping we get a positive answer. 8 sine 61, close bracket, minus, oh, hang on, Mr. Dueck. Oh, you did open up a bracket. Minus 0.24 times 16.5 cos, no, not yet, times 9.8 cos 61, close bracket, minus 12 times 9.8, close off the top. Oop, got a typo, Mr. Dueck. M2G sine minus mu M2G cos minus M1G, close bracket, divided by bracket, 12 plus 16.5. Oh, is that right? Accelerating, but barely. 0.17, I'm going to write 0.176, but I'm going to store this on my calculator. Because this isn't what they asked us to find. Arnica, what did they actually ask us to find? We're going to look at an individual mass to find an individual force. Which mass would we pick if we were clever because it's less cluttered? Yeah, which way is M1 accelerating? So which way is the winning direction? Same answer. So looking at M1, which force is pointing up? Losing equals M1A. And we need to get the T by itself. This is not a swappy dance. This is just plus the M1G over. I'm going to get tension equals M1A plus M1G. I'm going to get M1, 12 times my answer button, plus 12 times 9.8. And I get 119.7, I guess 120 newtons. So one question I may give you is an Atwood machine with a ramp. Or I may give you a ramp and have you do something with it. I'll wait a little bit. People are still writing. Okay, is that okay? Yep. So, B. A block has an initial speed of 8 meters per second. It's sliding down an incline with an angle of 28 degrees as a coefficient of friction between the block and the ramp. After sliding for 6.4 seconds, how fast is it traveling? Okay. Peyton, what's this actually asking me to find? Can you be more specific in terms of physics speak? Which one? Initial or final? Read the first line and then you'll figure it out. Yeah, why? Yeah, give me the initial. Okay. So, hey, VF equals question mark. VI is 8. And I noticed that they gave me a time, 6.4. Hey, what else do I need if I want to find VF? Yeah. I need the acceleration. I'm going to need to fill in this blank, and then it's going to be easy. It's going to be VF equals VI plus AT. So how am I going to find the acceleration? Hey, this is a job for a free body diagram. Peyton, what are the forces acting? I mean, if you want to, you can put the 5.2 kilograms there, or it's in the question. It's really up to you. And we have a 28 degrees right there. This time I know which way it's sliding down the ramp, so I know friction is going to be pointing up the ramp. And it says mu equals 0.12. All right. Peyton, what are the forces acting on this block? Get the obvious one. And so only one mass, and I'll put the mg on the same side as the pointy part of the ramp. Did I say ramp? Components, we pause, let's do that. It's going to be perpendicular, stopping right there. Parallel. Color, color, color. Color, color, color. Are we sinking into the ramp like quicksand? Are we flying? So there's going to be a normal force, and it's going to be the same size as the perpendicular component. It's going to be at right angles to the ramp. I'll eyeball it right about there. Peyton, does this question want me to include friction? How do I know? Which way is the ramp sliding? The ramp. So which way is friction going to point? No, you have. Yes. Who's winning? Probably down the ramp, although it could be slowing down because it just said how fast is it traveling. It's possible we're slowing down, and after 6.4 seconds, maybe we're doing 2 meters per second. But I'm going to assume mg parallel is winning. So I got lots of room here. I'm going to say winner minus loser equals ma. Little reminder note, Peyton, friction is what times what? I don't know the normal force. Oh, but look. You know what? It's going to be mu mg perpendicular. And we want to find A, Peyton. How would I get the A by itself? Yeah, you know what? Actually, I'm going to leave the M for one line because I think there's going to be an M in here and an M here. I have a feeling the M's are actually going to cancel. But if you're not sure, don't panic. Let's do our trig. Mg 2 lines, Peyton. Yes, it's going to be mg sine theta minus mu mg perpendicular. Which trig function is perpendicular, not sine? Of course it is. MA. Yeah, I kind of snuck ahead, but is there an M in the first term? Yes. Is there an M in the middle term? Is there an M in the last term? Conveniently here, masses cancel. And I can just find the acceleration. It's going to be 9.8 sine 28 minus, what's mu? I don't know, what's mu with you? 0.12 times 9.8 cos 28. Do y'all get 3.56 and change? Double check me. Yeah. So I'm going to write 3.562 meters per second squared. And now I'm going to go walk that up to here. Way up here. 3.562 meters per second squared. Hey, Peyton, I'm looking for an equation that's got a VF, a VI, a T, and an A in it. There is one. Yeah, and bonus, the VF's already by itself, so now it got a lot easier. Final step, VF is going to be VI plus AT. It's going to be 8 plus my answer button times 6.4. 8 plus answer button times 6.4. And I get 30.8. Is that correct? Meters per second. In this case, I asked you to find V final. I wrote a little note here. I could ask you to find B, use a different equation. From this one, you'd end up using D equals VIT plus a half AT squared. I could ask you to find mu. In other words, I could give you the distance, or I could give you enough information that you could find the acceleration and you could find the coefficient of friction. So I could tell you VF, VI, and T. You could find A here, walk your way here, and get the mu by itself. That would be fair game as well. We did stuff like that too. The third type of force question, this is probably what we'll finish with today, lawnmower questions. Here, instead of the ground being at an angle, the force is at an angle. Did I say angle? Components. Here, because the ground was level, we'll break the force into horizontal and vertical. If the ground was slanty, it was easier to change gravity to match the ground. Here, the ground is good. We'll change the force to match the ground. So I'm going to go like this. d. I called that Fx. d. I called that Fy. And it says if there's a coefficient of 0.25, mu equals 0.25, find the acceleration. Okay. Megan, this one was a little trickier. Which way are we accelerating if we're accelerating at all? To the, starts with letter R. So which way is the winning direction? Same answer. So which force is winning? Yes, Fx. Which force will be losing? Probably friction, but we haven't, you know what? This is a job for a free body diagram. What are the forces acting on this, Megan? Get the obvious one. Okay, so I'm going to have gravity down. This is my F applied, but it's at an angle. I'll never use it. I would do components. I'm going to draw in a normal force. Folks, is the normal force here going to be bigger, smaller, or the same size as mg? Spoiler, it's not going to be the same size. Why? Because this is lifting up. If instead we were pushing down at an angle, I would have a diagram that looked like that, and I would have a bigger normal force. That would be an easy way for me to make up a different type of a lawnmower question. But here we're lifting up, and so I'm going to really make it stupid obvious and exaggerate it. I'm going to go, there's my normal force. And which other force am I missing, Megan? Friction, which way? To the left. And so I think the tug of war here is between Fx and friction. My basic equation is going to start out winner minus loser equals ma. But I'm going to have to find Fx and I'm going to have to find friction. Color. Is Fy opposite, adjacent, or hypotenuse? And this is hypotenuse. Which trig function is O and H? Is Fy sine? Then you know what Fx is? Of course it is. So I think I can say here it's going to be F applied cos, and I'll just put a theta, making it general. Minus, hey Arnica, what was friction? No, what was friction? The equation you told me about a few minutes ago. Yeah. And I don't know the normal force, and that's going to take some work. In fact, I'm going to go off over to here. Megan, are we sinking into the ground like quicksand? Are we flying like Superman? What that really means is everything down equals everything up. What's everything down? Mg. What's everything up? The normal force and Fy. If we were pushing down at an angle, I would have mg plus Fy equals the normal force. I want the normal force. That's what's going to go here. So how do I get the normal force by itself? So the normal force is going to be mg minus Fy. Fy. So the normal force is going to be mg minus F applied sine theta. And you could walk that whole expression in brackets and put that right there, or you could crunch it. And because it's about a 50-50 split, I've noticed, I'll crunch it and I'll do it algebraically, so you can pick whichever method you want. If I were to crunch this, it would be 87 times 9.8 minus 575 sine 56. And that would give me a normal force of 87 times 9.8 minus 575 sine 56. I get a normal force of 375.903. Anybody else? I need a confirmation to make sure I haven't made a typo. We're good. And so I could put that there. Or again, I could walk this whole expression over. I'll do the rest of this algebraically by walking the expression over, but you could just put your answer button there. So how would I get the A by itself, Megan? By M. So it's going to be A equals, what was F applied? 575 cos 56 minus, what's mu? I don't know, what's mu with you? 0.25. And then you could either go mg minus F applied sine theta. I need to move this down a little bit because I'm overlapping. Yoink. Or you could just put your answer button right there. All divided by m. And now if I crunch all of my numbers, A is going to be 575 cos 56 minus 0.25 bracket. M was 87 times 9.8 minus 575 sine 56, close bracket, divided by 87. It's going to be bracket 575 cos 56, close bracket, minus 0.25 times. So here's using my answer button method, close off the top, divided by 87. I get 2.6156. If I did it just typing everything in, 575 cos 56 minus 0.25 bracket 87 times 9.8 minus 575 sine 56. Close off the trig, close off the mini bracket, close off the top, divided by 87, and I sure hope I get the same. I do. 2.62 meters per second squared. We're going to pause here. I was hoping to get to work and energy. Well, you know what? Here, I can get through it. I wrote this. There won't be a separate question for work and energy. I didn't put that as a section, but you should know the law of conservation of energy, GG. I snuck that in other locations. It was easy enough to add that as a part B or a part C. Okay? So, on Wednesday, we'll review circular motion, gravitation, maybe circuitry. Let me hit pause.